Today we're going to learn how to find the mean absolute deviation. We call it MAD for short. As we do these notes, it's going to be important that you have your calculator and that you practice along and not just copy down what I have. If you don't practice using your calculator, this is going to be very, very difficult for you. So grab your calculator and make sure you practice what I'm doing and not just copying down the answers. First, we're going to get down our vocabulary. Our first vocabulary word is mean absolute deviation. So the first part of this definition is mean absolute deviation describes the variability of a set of data. So it's going to tell you what that means is how the data varies. Then the most important part of the definition is the mean absolute deviation is the average distance between each data value and the mean. And remember back at the beginning of the year when we talked about distance and how distance is always positive. So even if you drive backwards in your car and you drive all the way to the grocery store backwards, the distance that you cover would still be positive. So that's why we say absolute, just to kind of emphasize that it's the positive part, because we're talking about distance between the mean and each data value. So it's just an emphasis on the absolute value part. All right, next we're going to write our algorithm. All right, so the algorithm, some of you are going to hate doing this because it's just a lot of what I call plug and chug. You're just plugging numbers into the calculator and getting an answer. So it can get kind of boring and kind of tedious, but at the same time, once you kind of get the algorithm down, it's relatively simple. So the first step of the algorithm is you're going to find the mean of your data. So remember, that's where you add all the values up and then you divide by how many is in your data. And if you don't remember that, you might jot yourself a little note so you remember how to find the mean. Then our second step is we're going to find the distance between each data value and the mean. And so what we're actually doing is we're subtracting the value minus the average, the mean, and then we're taking the absolute value of it. So that's what's written in parentheses, kind of the practical part of what we're doing. And then the last step is we're going to find the mean of those distances. All right, so there's the last step written down, find the mean of those distances from number 2. And I think when you see this in example, it will make a little bit more sense. So let's look at example number 1. Example number 1 says find the mean absolute deviation, and it says you're given the following data set. Find the mean absolute deviation. So the first step is to find the mean. So we're going to take 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 16. You're going to add those up in your calculator, and this is the part where I told you at the beginning that you actually need to do it. So get your calculator and add those up. You should get 72. And then we're going to divide by 8 because there's 1, 2, 3, 4, 5, 6, 7, 8 numbers in my data set, and that comes out to be 9. So my mean is 9. All right, then the next thing that we're going to do, and I've put it in a table. We won't always put it in a table, but this just kind of will make this step a little bit clearer. So we're going to take those values from our data set. So we have 3, 6, 6, 7, 8, 11, 15, and 16. And then we're going to subtract, we're going to find the distance from 9, and that comes from my mean. So I'm going to take 3 minus 9, I'm going to take 6 minus 9, 6 minus 9, 7 minus 9. You kind of see the pattern all the way down. So 3 minus 9 is negative 6. The absolute value of that is 6. 6 minus 9 is negative 3. And again, this is where I recommend that you do it on your calculator. The absolute value of negative 3 is 3. That one's the same. 7 minus 9 is negative 2. absolute value is 2. 8 minus 9 is -1, absolute value is 1. 11 minus 9 is 2, absolute value is 2. 15 minus 9 is 6, absolute value is 6. 16 minus 9 is 7, absolute value is 7. Okay, so there's what your table should look like. Then I want you just to see a visual one time so you kind of know what we're doing. After we do it this one time, I probably won't ever put it on a number line again. But here's what it looks like visually. Here is our mean. So our mean is 9. And then our first data value is 3. So right here. And the distance between 3 and 9 is 6. So that was that first absolute value that you wrote in your table. Then our next data point was 6. The distance between 6 and 9 is 3. Then we had another one. That's also 3. Then we had another data point at 7. The distance is 2. And then we had one at 8. And the distance between there is 1. And then if you look on the other side, we had a data point at 11. The distance between that is 2. We had a data point at 15. The distance between that is 6. And then we had a data point at 16. And the distance between that is 7. So that's just kind of a visual. Like I say, I won't ever have you do that again, but I want you to see that what we're looking at is the distance between our mean, which is 9. All right, so step 3, look at the absolute value column, and then we're going to find the average of the absolute value column. So our absolute value column was 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7. Go ahead and add those up on your calculator. You should get 30 divided by how many is in our data set, which is 8, and 30 divided by 8 is 3.75. So this means that the data value average is 3.75 distance-wise away from the mean. All right, go ahead and do the on your own. You're going to calculate the mean absolute deviation for the following set of numbers, and then come back and check your work. All right, so when I added those numbers up together, I got 600. I divided by 6 because that's how many is in my data set, and I got 100. So then step 2 is to take each value minus your mean. So I did that. And then the third step is we're going to look at these numbers. We're going to add those up and then find the average. So when I add those up, I get 92. So 25 plus 17 plus 4 plus 0 plus 21 plus 25 is 92 divided by 6. And that comes out to be 15 1/3 or 15.3 repeating. So my mean absolute deviation is 15.3 repeating, or 15 1/3. All right, example 2 says find the mean absolute deviation. You and your friends have just measured the heights of your dogs. Find the mean absolute deviation. What does this mean absolute deviation tell you? All right, so go ahead. The first step, we're going to add the heights of the dogs together. So we have 600 plus 470 plus 170 plus 430 plus 300. Add those up on your calculator. You should get 1970 divided by 5, and that equals 394. So the average height of the dogs is 394 millimeters. Then we're going to do that long drawn out process where we take 600 minus 394. Then we're going to do 470 minus 394. Then 170 minus 394. And notice how I'm skipping this step. I'm just going ahead and using the absolute value sign. Then 430 minus 394. And then 300 minus 394. So we're going to add all of those up. 206 plus 76 plus 224 plus 36 plus 94. You should get 636 divided by 5, and that comes out to be 17.2. So what that means is the dog's heights on average are, it should be 127.2. I wrote that down wrong. Let me erase that. 127.2. So the dog's heights on average are 127.2 millimeters from the mean. All right, and then if you ever want to check your work, this might be a useful check for you. Deviations on one side of the mean should equal deviations on the other side. So if you were to look at that number line that we did in example 1, and if you were to add all of the numbers up, all of the distances on the left side of 9, that should equal the distances on the right side of 9. So that might be a check. I sometimes think after you get done plugging in all these numbers, the last thing you really want to do is check. But if you ever want to, that is just a good way to check yourself. Okay, let's look at example 3. We're going to do some comparisons. So the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in the millions of dollars and rounded to the nearest hundredth. So what we need to do is we need to find the mean absolute deviations for each set of data and then round to the nearest hundredth. I'm going to do these, I'm going to work them kind of side by side so you can see. So the first thing that we need to do is find the average, or find the mean. So do that for the top 5 and the bottom 5, and you can do that and then come back and check your work. Okay, so the first thing that I've done is I've found the mean salaries for the top 5. It comes out to be $23.40 million. And then I did the same thing for the bottom 5, and it comes out to be $0.43 million. So check your averages and make sure that you got that. And then so I have room to work, I'm going to have to erase this, so make sure that you've got that down. Okay, so then in the second step, I've done each data point minus the mean, and I've added all of those up. And then I'm going to take 20.96 divided by 5, that's how many's in my data set, and I get 4.19. So the mean absolute deviation is $4.19 million. And then I'm going to do the same thing for the bottom 5 salaries. Okay, so I've done the same thing for the bottom 5 salaries, and then I've added them up, and I've got 0.07. So I'm going to take that divided by 5, and I get about 0.01. So my mean absolute deviation is $0.01 million. Okay, then the last part of this is we need to compare. So let's go ahead and look at the last part of this example. Okay, so the mean absolute deviation for the bottom 5 salaries is much less than that for the top 5 salaries. Data for the bottom 5 salaries are closer together than data for the top 5 salaries. So now notice how I'm comparing the mean absolute deviation as well as the data when I wrote my comparisons. So kind of keep that in mind when you do yours. Do the on your own and come back and check your work. Okay, so I did not show all of my work in this lesson. If you need to come see how to do it, come see me in the morning. but the average for comedies is 94.2 minutes. The Mad is 41.6 minutes. And then for drama, the average is 132.8 minutes, and the Mad is 12.24 minutes. And then the comparison is the mean absolute deviation for comedy is less than that of dramas. Data for comedies is closer together than that for dramas. So if this doesn't make sense because I didn't show my work, come see me and I will work through how to do it with you. If you have any questions, please come see me.